on-off switches on the floor, just where I want to put my foot. So if anything exciting happens, you know what it was. Good afternoon. I'm Alex Perry. I work at Google down the road. And I'm here to talk about monitoring. Well, specifically, I was going to talk about monitoring from the point of view of, bit more volume maybe? Monitoring from the point of view of DevOps. The reason for that is that I've come across a lot of people who have an idea on of how monitoring works, which works well if you're not in a DevOps setting, and then they try and do DevOps with monitoring working the same way. So really, I'm going to try and explain how I see monitoring working in this context. Like I said, I'm down the road. I'm in what's officially called the LA office, which means LA County, because we're in Venice. And down there, I work on court monitoring. To clarify, court monitoring is what other people might call enterprise monitoring. But if I said enterprise monitoring, you think of the Google Enterprise product. So we call it court monitoring. It's less confusing that way. So in that sense, it's just normal DevOps-style court monitoring. But from the monitoring point of view, if you bring up a monitoring system, what is it that you expect your monitoring to page you for? What is the stuff that you expect and have to be woken up in the middle of the night for? And these are the kinds of things which people seem to come up with when I say, what do you think pages you at Google? And it's a drinking game kind of thing. And if they guess something would get me paged, then I drink the beer. And if they guess wrong, they drink the beer. Or, and the evening goes quite quickly. So these are the kinds of things that people come up with, and they're convinced these will get me paged. And so really, this talk is explaining why I think it wouldn't. So let's talk about some of those. One of the arguments I've had people make is that you would expect to have these things page you in a big deployment because you're big, or you'd expect to have them page in a small deployment because you haven't bothered to set your system up right. So one of the things to think about as I talk about this is, do I ever actually mention inherently being an enterprise or a small company as being a distinguishing factor? So the first category is hard failures. Whether it's a box or a rack or a data center, if the entire thing goes down, do you need to get paged? And in many cases, people assume that you do. People certainly seem to assume that I'm going to get paged if Google loses a data center. And no, the quick answer. But really the thing to do is, if you actually lost something as big as a data center, as small as a machine, the odds are the reason why it went away, it's not coming back anytime soon. It might be coming back soon on the time scale of you as a human, but it won't be coming back soon on the time scale of your users who are seeing an SLO violation. So either you've just agreed that you're going to take an SLO violation every time anything dies, or you have to make sure that your DevOps-driven automation will fix it without you. And once you've agreed that that automation will fix it without you, why are you being paged for something which will fix itself? So hard failures are actually an easy one. Hard failures you should be able to completely avoid being paged for. What's more interesting, though, is when you've lost some hardware, and if you've got a large installation, you're losing hardware all the time, which hardware are you more interested in replacing? There's an opportunity cost in leaving it broken, and you'd like to really fix that stuff. Now, the question is, if you've got a broken machine, the obvious thing to do is to replace that machine, or bring it back up or something, to do the same job as it was doing before. Think of that as a default. Now you know the opportunity cost of not getting around to it sometime soon. But the amusing thing is, when you bring that box back, especially if you have to reinstall it, it doesn't cost you anything to make it do something else. So the real opportunity cost is, what would I do with this box if I was reinstalling it from scratch right now, and it could do anything we would ever want to do in this facility? That's the real opportunity cost. And the opportunity at the reinstall time can be much higher to use it for something else right now. So you start by saying the opportunity cost is put it back to what it was doing, and then you go, oh, but we could do something else. And figuring that out and then deciding what to fix is really the interesting bit. Now, if you're going to say that, and say that we're going to have an opportunity cost and rely on that to drive hard failure resolution, then from the DevOps point of view, how do you know that you have that answer right? If you don't know you have that answer right, then you're going to have to babysit the system. And so what you really need is an alert which you can trust. Not from the human point of view, but from the point of view of detection of a failure. And how do you detect failures reliably? You build them to build your DevOps test flow to make sure that every time you do any kind of testing, you make sure that all of the failure detection stuff fires. Every single one of them. You bring up a load test. At the end of the load test, one of your options is to terminate the load test by taking down your simulated data center. Do that, see how fast the traffic drains. Oh, and make sure that the data center fail stuff fires. Don't just bring things up and down cleanly every time. Set up tests which break things and then make sure that your automation kicks in to try and fix the break. If you do that, then you can trust that the resolution of the failures is working. Similarly, the bit where we're looking for the maximum benefit for the repair, the initial one, where you use it for the same thing again, is a good first guess. Run all your flows on that basis, but just make sure you can always upgrade that opportunity when somebody comes along and says, I'd like that machine, seeing as it's down, could I have it please? And some completely other system can steal it away from you. Soft faults. Soft faults are usually considered the ones where, oh my God, you need a human because you don't know what's wrong. But again, on an SLO thing, the thing you're going to do is to drain away from it. Now, draining is a scary subject. Every service needs a different way of draining. How do you know whether you've got your draining right? One of the things from the DevOps testing point of view is you can build tests which make sure your drain automation works. But here's the important thing to worry about. Your drain automation is probably running off of monitoring. How hermetic is your test framework? If you're going to build a test which proves that your drain system works correctly, how do you know that that drain system was only using the information that you were providing as part of the test and wasn't reaching out to the rest of production? If you're not sure, then what you've just done is proved that in normal operation, the drain system works fine. That's not really where you want it to be. So making sure your test framework is hermetic, and to the extent that you can't, making sure that you're actually logging all of its network traffic to the rest of the system is a really important way of making sure that you know you can drain without a human watching. So hermetic DevOps releases is important, especially when you're trying to do operations. The fun thing about binaries you use in operations is the fact that they're actually touching the systems. Therefore, they're much more likely to be non-hermetic than the things which are merely trying to be a serving system. Once you've got decent coverage on your drain system, so you know exactly what all the information is going in and out, and you can test it, then you know that what's going to break is configurations. And as soon as you know it's configuration pushes that can break something, you also know how to roll it back. So the key here, if you'd like to be able to have drains that are reliable, such you don't have to be paged for them, is to absolutely consider your drain system to be a more critical binary than everything else. Binary not in the sense of you write it yourself, but binary in the sense that you package it and you put it through a release flow. Another aspect of this, and this is where we come back to explicitly mentioning monitoring as opposed to implying it, is that your monitoring is going to be doing things like telling you that things are broken and you have to drain. So if you're worried about whether your drain system is working, given its configuration make sure you drain regularly on things that don't matter, just to find out whether it works, just to make sure that you haven't baked something into the configuration that broke it since the last time you tried it. So maybe have some monitoring which detects the fact that for the last however long, the drain system hasn't done anything. And therefore, you need to try and break the drain system just to find out whether it breaks. That way, if you're going to do a test like that, you're doing it when you're watching. So the alert fires and says, next time when you get into work and you've got a cup of coffee, please try and drain something, and if it breaks, fix it. At least you don't have to get paged to find out when it broke it for you. The other thing is that the practical reason why you're draining is to move traffic around. If you know that the traffic has moved, you're okay. But what happens if the drain system worked but didn't move the traffic? The monitoring is the key thing that will tell you whether the traffic moved. And you can have alerts that tell you that the traffic did not move. Fine. So I just said create an alert which pages you when you try to drain a site and the site did not drain. Bear in mind, I also said have your automation drain things unnecessarily regularly. Don't forget to explain to your monitoring system that when the drain was only being done to test the drain system, those are the ones you don't need to page for, because actually the thing we just drained is completely fine. Okay? At that point, the drain system will try and drain, it will try and undrain, find out it didn't work, and leave you a little note as a bug for the morning. Because everything's actually right now, it's still fine. Now, given we're very sensitive to configuration in this, because the configuration is the unknown, you can record the configurations and you can play them back as a regression test to make sure that any exciting drain failure modes you discover don't repeat. Don't just consider the drain configurations to be this black box thing that you use today, throw away tomorrow, and you never ever see again. You should be able to play them back. Another aspect that comes out of this is the fact that the load balancer, which you're effectively using for draining at this point, may continue to allow users to reach a service that's open. That doesn't mean the drain failed. It means that you didn't realize, as part of your real-time test coverage, which is what your monitoring is, you didn't realize that it was broken. This is the monitoring equivalent of a missing test. You're going to create the test real soon, but right now, you actually have a broken system because you have a missing test. You have two choices at this point. You can page for it, or you can teach the system to deal with it itself. If you have an N+2, for example, production deployment, most of the time you're going to have a piece of redundancy somewhere. You have the option of using that redundancy to drain yourself away from something which you're not quite sure whether it's okay. That doesn't mean it's broken. It's just that given that nothing else is broken, let's get out of the one that we're suspicious of. And that's just completely allowed you to avoid worrying about that little canary that you've got running there, which is doing something odd. And again, what you're doing here is watching user behavior and going, wait, they're logging in and then leaving again and not coming back. The ones which are over in Europe, they're sticking around. There's something odd going on. Something like that is something you can write code for to recognize. But you can't safely run it unless you've got the drain system that you trust, which will do those drains on demand. So in this sense, you're using monitoring as a unit test. Another aspect, when you're dealing with loss of capacity, draining and undraining, I've seen people getting paged because they're down to N+0. Okay, you've got to bring capacity back up again. But what was this about having automation that will try and do repairs? If you don't have any automation doing repairs, then what you've really just guaranteed is that when you're N+0, you'll page somebody who'll wake up in the middle of the night and start trying to repair things when they're half awake without using automation. This is, of course, reliably successful. Wouldn't you rather give them some automation which will probably work? And then the real question you're asking at 3 in the morning is, should I run this without asking you any questions you might get wrong? And one of the things I've had people say is, we're a small facility, we can't afford to go N+3 or whatever. And the usual answer to that one, which in theory people in this room should know, but I'm reminding you to tell people this, is if you make your virtual machine smaller, you can have more of them. So the final one I've come across that surprises people is from the point of view of capacity management. If you've got a disaster somewhere, and it's taken down sort of one of your units of reliability of everything because you've taken out your favorite, I don't know, your favorite data center, or you've got network connectivity problems into a continent or something. It's taken out effectively at least one of your resiliency counts for everything. It'll take out more than one of some things. Those things could do with some extra capacity somewhere else. Other things it only took out one of, and you went from, say, N+3 to N+2. What you'd like to do is to take all of those resources, which you'd still like for redundancy, but move them from the place where it's not really desperately necessary right now for the next 2 hours, and move them to where it is. And that generally means taking machines and reinstalling them, wiping virtual images, whatever you're using as your virtualization strategy, to move them from one case to the other. You can do that by hand, providing you're confident you won't make things worse by making a typo as you go along. But the reason why you define redundancy is to have common failure modes. So if you know what your common failure modes are, you can play it the other way and go, please give me a common failure label, like European network or something like that, and tell me how many machines are ones which I could take down and only have that failure mode, i.e. how many machines are we running in Europe that are behind this network? And you can ask that for each service, so you can find out how much capacity you can recover for any service and gain at the price of 1 unit of resiliency. And then you can turn around to the other service, which is at n+0, and go, how many machines would you like to have in Europe that would get you 1 count back? If you have the data that traces through what the dependencies are, then you can perform that calculation automatically. And the useful alert you actually fire from the monitoring is coming out of that DevOps calculation, which is, remember, a deployment tool. What I just described is a deployment calculation. Use that deployment tool, white box, as a monitoring tool to give you the answer that you like to have, which is this service is running at n+0, this service is running at n+3. Do I have permission to take them to n+1 and n+2? Because everything beyond that is just automatic deployment. We have recipe systems for that. Take your pick of which one. You shouldn't need to have a human involved to do a step like that. The first few times you will want to have a human involved. If you trust your deployment systems because you're using them all the time anyway, then why shouldn't they be handling this one? So the conclusion of my silly question at the beginning was, if you've actually used DevOps to trust your operations tools because you're actually running tests against them, you've written them to be hermetic so that they work also when your systems are broken as well as when your systems are in normal operation, then there's no need to page for problems. Monitoring is not something you use to get a human's attention except in the extreme case. Monitoring is the thing you use to provide non-hermetic testing. You can't call it testing because anybody who writes a test considers a test to be something which should be hermetic. Okay? So it's not testing. But what is it? It's non-hermetic testing. It's testing where we are allowing the inconvenience of users to derive the test. If you're careful, you can write the code both ways. You can write a test which runs both hermetic and non-hermetic and hope that they behave the same. That was it. Any questions?
Any questions? Sure.
Oh,
100% would be impossible.
I didn't. You mean test coverage or what?
Yes. For the negative and positive, as you described.
The question he asked was, what percentage of coverage do we think we're at? And what I'm looking at is wondering how to put a number on it. We do fairly well, but I'm not quite sure how I'd go about characterizing it. The real challenge I see, to refer you to earlier in the talks today, is that I don't have anything which gives me a good handle on entropy. So as the systems are running, they're accumulating entropy, but at any given time, I don't know how much entropy is out there. I'm not tracking that. And as a result, that entropy is really what I'm fighting. And until I have a good handle of that, then I'm not really in a position to do that kind of the automation steps that I'm talking about in as robust a way as I would like.
How would you gauge entropy?
An easy way to again use the concepts from earlier. Let's look at it from the promise point of view. What combination of promises is in the history of a machine since it was last completely wiped? Now that I have that history of promises that is defining the possible state it might be, what collection of distinct collections do we have across the fleet? If I have two distinct collections and they're distributed such that I could lose either of those collections and still have a working system, then what I really have is a common failure mode, which is one of those could suddenly do something exciting, and I would lose that half of my serving infrastructure. So if you know what your entropy is, then you can spot a significantly large failure pattern which is latent and waiting for you. And suppose instead of it being 50-50, it ended up being 80-20 in terms of accumulated history. Everything I've said here still works. But you're now in a position to say that we have this latent risk that this historical pattern of machines has a common failure that we're waiting to have trigger. At which point you gratuitously go off, drain 20% of that 80% and do something to it. Reinstall it. Just change its history in a massive way. Get it to the point where you think it's still going to serve. Bring it back up. Just try and make the fleet more diverse in the way where you believe they're all equivalent, so you don't care. But if it turns out they're not equivalent, you're in a position to do something about it, because it won't be catastrophic. I'm not saying inherently go off and run lots and lots of versions of the binary for the sake of it. That's not the point. The point is to take the variables that you don't understand and randomize them so that you will be in a position to detect when they're a problem. That's the bit that we don't really have a good handle on in the sense of what I'm talking about.
All right. I have a next question over here. How long does it take for you to learn about a system and then be aware enough that you know which tests could be used and to take down systems based on a monitor? Because that seems really scary that you would take down a system, reprovision it as another one, just based on when you're not around. What level of concern would you have before you started, you know?
The risk there is more. Let me turn this around and say, if you have drained something, what is your confidence it might accidentally start serving again? If you've got enough confidence in your draining system such that you can verify several different ways whether the drain worked, and be of no doubt whatsoever we might actually screw up and start sending traffic back, now you can safely reinstall. The only thing you were concerned about then is, was my calculation of redundancy wrong? And between those two things, the risk there isn't particularly big.
Any other questions for Alex? Good. Let's keep it going.
Although you had said that these technology or the outages really don't depend on the size of the organization, small organizations, it's hard enough to get dev leaving enough time for QA to validate the product. In a small organization, how do you then get people to appreciate that automation and self-healing systems and monitoring are something of value that, you know, when you can't even get QA to be a valued part of the process?
There's two aspects to QA. There's a bit where, does the person who owns the product really actually care whether it works? If they're the standards that they hold the product to, which is it'll kind of work most of the time, then you've got two consequences, one of which is QA is less valued because you're going to use your users for testing. But operationally, it's the same. You're going to use the users for testing. You know, if it goes down, somebody will call up a friend working at the company and let them know. So QA is, in many ways, it's just a specific aspect of the tests which DevOps worry about. It just happens to have humans involved. It makes it somewhat less hermetic. But yes, you have to have people care about QA. DevOps is a way of, among other things, automating QA. And there is an advantage to taking this kind of a model in a company that is not entirely convinced QA matters, because if you build a N+2 serving system, you choose to use one of those temporarily for QA, you're still at N+1. You just can't undrain this thing which is running what is now the canary version for QA purposes. In desperation, you would use it, but you're hoping that will never happen. And then once the QA work is done, you can move it, you can reinstall it back into the main production version, and now you're back up at N+2 while people decide whether to actually make this the release or not. So making it such that you've got confidence about your drain and reinstall systems allows you to repurpose fleet from production to test to QA to canary to the devs trying something really wacky, which otherwise you would buy more machines for. You wouldn't have a choice.
Hey, last question over here.
Okay.
I hope this doesn't take too long, but I've heard you use the word drain as both a noun and a verb, and I have no idea what you're talking about. I've never heard it used in this context. I'm probably the only one in the room, I know.
Terminology is fluid. People invent words for various things, and it'd be nice if there's a dictionary that we all agreed with before we started doing DevOps.
Well, actually, it's an old IBM mainframe command, too, to drain a queue, like a print queue or something.
And so...
Of, like, print jobs. So you're going to...
Yeah, but it's the same concept. When you have a service that's doing something like being a web thing, and you decide to stop having it do that for the users. If you just turn them, in a sense, if you just turn it off, then all of the users who are currently using it will be unhappy. So the drain process is the one where you try and make sure that it terminates cleanly and the work goes somewhere else without the people currently using it minding. So the term does come over from the old uses like draining a print queue, because if you just turn off a printer in the middle of somebody's print job, they'll be irritated. So it's polite to let the existing print jobs finish printing before you turn off the printer. So draining and undraining is something which is in principle a switch that leaves you from using it to not using it. But in practice is a more gradual thing because we don't want to impact the users when you do it.
Hey, thank you very much, Alex Perry.
Thank you.